Hello, everyone, and welcome to a lesson on rates of change and tangent lines. You can read along with me here. The average rate of change of a quantity over a period of time is the amount of change divided by the time it takes. Another way to think of it is that the average rate of change of a function over an interval is the amount of change divided by the length of the interval. In other words, it's a big fancy way of saying slope. So when somebody says find the average rate of change of f of x is equal to x cubed minus x over the interval 1 to 3, we're really just finding the slope between x is equal to 1 and x is equal to 3. So as you know, you need 2 points to find slope. So be careful when they give you an interval. That's not really what you want. You want the 2 points. So we're going to have to go back and find why. F of 1 is 1 cubed minus 1 is 0. So if you were making a little sketch of it, now we know that at 1 it's 0. And f of 3 is 3 cubed minus 3 is 24. So that's pretty high. I don't know, somewhere way up there. And of course, that's not enough to graph a cubic function. All year graphing functions, I'd really like you to think about factoring them. Because once you factor, you have the x-intercepts. And once you have the x-intercepts, then you can make a pretty nice graph. So we're going to go like this. And it gets way up there. So the question that they're saying is, what is the average rate of change between these 2 points? In other words, what is the change in y divided by the change in x? So average rate of change, remember that delta means change, is slope, which is y2 minus y1 over x2 minus x1, which is delta y over delta x. So many ways to think about it. Find one that works for you. And we do get 24 minus 0 over 3 minus 1 is equal to 24 over 2, which is 12. That's the average rate of change. So honors, hate to do this to you, but I am going to have to share these videos for my own sanity. So I am going to talk just a minute about in AP, when they ask for average rate of change on the exam, if you fail to show the subtraction on the top, the subtraction on the bottom, and the division, you will not get the point for it. Even if you're thinking, but it was such easy numbers, I could have done it in my head. They don't care. They want to see the work. I have been trying to train you since you were freshmen or sophomores that I want to see the work. And that's why, because they won't give you the point without it. So a line through 2 points on a curve is called the secant to the curve. Now, it's a little hard for me to show it to you here because this line looks like the curve and the secant. So I'm actually going to just redraw it on a really curvy thing. So if I were trying to find the average rate of change between here and here as a triangle, you would have your delta x and your delta y. But this line, this is called the secant line. And that the slope of that line is the average rate of change. So you can't quite see it here. And it makes sense. I mean, the slope is 12 on that one. So it's super steep. But in general, if you draw a secant line, that's what's going to give you the average rate of change. So let's just think about what that means. That means if I were going to average all the slopes together, this plus this plus this plus this plus this. So you can see that sometimes the slope is steeper than the secant line. Sometimes the slope is negative. But if you took all those slopes and averaged them together, you would get this slope right there. So it's the average rate of change. So let's find the average rate of change in an actual word problem. We are growing fruit flies. Mr. Ward across the hall would be pretty happy about that. So the rate of change keeps the number of fruit flies that are growing is changing every day. So right here, it's changing pretty fast. And then it starts to slow down. And then the number of fruit flies is increasing at a much slower rate. But I don't want any of that. I just want the average rate of change. That's a beautiful thing. You can just find slope. So we've got 340 minus 150 over 45 minus 23. Go ahead and do that on your calculator. And you're going to get 8.6 flies per day. So I guess I didn't actually label my graph, but flies, and these are the day. So the average rate of change is 8.6 flies per day. Was it increasing at a rate of 8.6 flies per day here? Certainly not, much less. And right here, it was more than 8.6 flies per day, but that was the average. So here's what I want to know. I want to know what was the rate of change in the number of fruit flies on day 23. On day 23, how much was it changing that day? I'm giving you a second to think about it. If you really want to be a good thinker, you'll hit pause and you'll try and figure it out. So this is where I really, really miss being in class and generating some ideas with all of you. But a lot of people say, having done this for years, well, you could take the number at day 24 and the number at day 23 and then figure it out. I'm like, well, that'll be pretty good. That'll give you the number over from day 23 to day 24. But I want to know exactly at day 23. And the bottom line is you can't do it. You need 2 points to find slope. You can't find slope at a single point. And yet intuitively, we know it exists. There is a slope right there. There is a slope right there. There is a slope right there. And this is why you might have heard me say last class that this is my favorite lesson of the year, because this is what differentiates calculus students from algebra and pre-calc students. I am going to teach you how to find the slope at a point. Instead of needing 2 points, we're only going to need 1. So be prepared to have some fun today. Okay, so we're going to do this with x squared. I really am ready to let the fruit flies go. So here we go. Let's graph y is equal to x squared. You'll notice that I made a really funny graph here. I did that so that the graph would be curvy and we could really see what we were doing. But it's still going to be 1, 1. You see how I did that 1, 1? And then 2, 4, and then 3, 9. And I did that to make sure that I was going to be able to emphasize the secant line. Otherwise, it grows too fast for me. So what is the average rate of change from 0 to 3? That's easy to find. Remember, you have to have both points, 0, 0, 3, 9. 9 minus 0 over 3 minus 0, 9 over 3 is equal to 3. That's the average rate of change. But you can see it is steeper here. So this slope right at that point is greater than 3. But this slope right here is less than 3. And what we want to find, I didn't quite get it on my paper here to make everything fit, but we want to find the instantaneous rate of change at x is equal to 1. The instantaneous, this was a bad idea to write it out. I can't spell. The instantaneous rate of change at x is equal to 1. At x is equal to 1, what is the instantaneous, look, I did it, rate of change? So right there. You might want to take a guess what you think that number is. Hopefully you guess something less than 3. It is definitely not as steep as 3. All right, here's the tricky thing we're going to do. We're going to say that this point is the point 1, 1. Now, as you know, we need 2 points to find slope, so we're going to temporarily use a second point just so we can fulfill our trickiness. So my second point, I'm just going to make a little distance away. And I'm not picking a certain spot, I'm just drawing it just so you can see it. And I'm going to call this point 1 plus h. Now, if the x value is known, how do you find the y value? You plug it into this equation. So I'm going to do that. The y value is 1 plus h squared. Now that's not very helpful, so I'm going to just expand it. So I get h squared plus 2h plus 1. That's the y value. And then I'm actually going to calculate the slope. The slope is, now leave a little room. Don't write it right next to it. I'll tell you why later. y2 h squared plus 2h plus 1 minus y1, I'm color coding it so that you can follow along, over x2 minus x1, which is 1. Now, what value could you assign to h so this answer would actually be really close to the real answer? Maybe if h was just 0.1. What if h was 0.01? What if h was 0.0001? Actually, what if h was just 0? If h was equal to 0, this point would be 1, 1, because the h's would all be 0. So why not just let h be 0? Yeah, because of this down here. If I let h be 0, then I'll have a 0 in the denominator. But I know there's an answer. I know the answer does not exist because h is 0 in the denominator. I can see that there's a slope at that point. And this is where we get to use limits. The slope is going to be the limit as h approaches 0. So you know you want h to be 0. You want it to be as tiny as possible to actually find the slope right at that point. You really, really want h to be 0, but you can't. So we take the limit as h approaches 0. This gives us the limit as h approaches 0 of h squared plus 2h, the ones cancel, over h. Remember that for limits, your first strategy is always to plug it in, which you can't because you'll get 0 in the denominator. Your second strategy is to simplify and then try and plug it in. So that's what I'm going to do. And sure enough, when I simplify, the h's cancel. And now I get the limit as h approaches 0 of h plus 2. And now I no longer have to worry about getting a 0 in the denominator, so I can plug it in, and I get 2. The slope right there at exactly 1 is 2. I have literally used limits to trick the problem from needing 2 points to actually having the 2 points be right on top of each other so that they are 1 point. I found the limit. I found the slope at a point. This is the slope at x is equal to 1. It is the instantaneous rate of change. So an average rate of change means if I could take all these different slopes and add them up, the secant line would give me the average rate of change. But this one is going to be the tangent line. So I don't know if you remember the word tangent from geometry and pre-calc, but tangent means it just barely touches. So the secant line connects 2 points on a curve. The tangent line just barely touches. So it's the slope of the tangent line at that point. All right. I know you might not have gotten it yet. Don't feel like you have to keep rewatching this video, backing it up, and watching this section again. If you know me at all, you know I'll have plenty of examples to make it clear. All right, let's do another one. Write the equation of the tangent line to the curve f of x is equal to 3x squared plus 1 at x is equal to negative 1. You know what I want to do first. I want to graph it. Hopefully you know that it is a parabola from the x squared. It is facing up because it is positive. It is steep because of the 3. It has been moved up 1 because of the plus 1. But because it's not x plus or minus something, it has not been moved left or right. So you're going to go up to 1. And then instead of 1, 1, it's going to be 3 times as high. So instead of 1, 1, you're going to do 1, 3, 2, 3 on both sides. So it looks like this. There is a line that is tangent to, meaning just barely touching, at x is equal to negative 1. So when x is negative 1, right at that point is negative 1, 4. There is a tangent line. I'll make my dot bigger so it looks like it's touching. There's a tangent line there. I want the equation of that tangent line. My best advice I can give you is to start to write the answer right now. Put it in the box. It is going to be y is equal to m, I don't know the slope of this line, times x minus. So minus and minus 1 is going to be plus 1 plus 4. Look, the only 2 things you need to write the equation of a line are slope and a point. And you already have the point, so you just really need the slope. Okay, in case you need a little reminder, m times x minus x1 plus y1 is the formula for the equation of a line. So whenever the question says write the equation of a line, I would just jump straight to the answer, get most of it filled in, and then you can look at it and say, oh, all I need is the slope. So you need the slope at a point. So in other words, we're going to practice what we just did. So you're going to create a fake second point. It doesn't matter if you go to the left or go to the right. I'm just going to make mine there. That point is going to be negative 1 plus h. I'm going to make it as close to that as possible. Now I just realized I don't have enough room there, so I'm going to just move mine down a little bit. That point is going to be negative 1 plus h. And then the y value, now a lot of people have trouble with this. You have to plug negative 1 plus h into this equation in the same way you would to find any y value. So it's going to be 3 times negative 1 plus h squared plus 1, which is really not helpful. So I'm going to switch things around to make my life easier. You should be expanding it. You should try and do it without me. It would be really nice if you could expand and not just be rushing to copy everything down. Just hit the pause button, try and do it on your own. Phew. All right. There's my second point. So in order to find slope, you need 2 points. I know I've been trying to tell you that we're only going to need 1 point, but it's not true. You actually need 2 points. But we're going to use a fake second point, and it's going to be like we're only using 1 point. It's going to be very exciting. Remember to leave a little room. Slope in general is y2. I'm going to color code it again so you can see it. Minus y1, which is 4, all over x2 h minus 1 minus x1. So x2 minus x1, which is negative 1. But if I simplify this, leave a little room again, I would get 3h squared plus 6h. And because this becomes a plus 1 over h. Okay? So my goal is to make h as tiny as possible. Because if h is literally 0, if h is equal to 0, then the second point would be negative 1, if h was 0, 0, 0, 4. If h was 0, then negative 1, 4 would be the second point. And that would be perfect, because then I'd be finding the slope at negative 1, 4. The 2 points would be right on top of each other. But you can't let h be 0, because if you let h be 0, you'll have a 0 in the denominator. And how do we solve that problem? When you know there's an answer, you take the limit. The limit, as h approaches 0, you know there's an answer. You try and plug it in and can't. So your second strategy is always to simplify. I'm going to do that by factoring h plus 2 all over h. The h's simplify to 1. H divided by h is equal to 1. And then I'm just going to wrap that around here. So the limit as h approaches 0 of 3 times h plus 2, now I can plug 0 in and I don't get an error anymore, gives me 6. I'm just looking at this thinking, does that look like a slope of 6? It does not look like a slope of 6. So then I have to ask myself, where did I make a mistake? And you might have already found it. You might have been like, oh, if you were in class, you would have screamed it out to me, Mrs. Shaffer. That's great. I miss class. But this is going to happen to you. You're going to get the wrong answer. You're not going to know why. But I knew that it was wrong, not because I have a key. I actually don't have a key in front of me. But because I'm looking at this line thinking that green line definitely has a negative slope. But it does look like it could be 6. It looks pretty steep. So I go back up to my work and I see I made a copy error. I wrote 3h squared minus 6h, but in the original, but then I accidentally changed it to a plus. So I'm going to go back here and change that to a minus, which is going to change this one to a minus. That didn't work so well. Give me a second. I like to be neat. Which is going to change this one to a minus. And now I am going to get negative 6. Okay. So the slope right there on that green point is negative 6, which looks right. Okay. So I can put that in right here. Now you are not required to multiply this out. This is considered an acceptable answer on the AP exam and in my class for all my tests. The only reason I'm going to multiply it out is because it's a great way to check. So if I want to check, I would be looking to see if my b came out to be something negative. So y is equal to negative 6x minus 6 plus 4. Y is equal to negative 6x minus 2. So the y-intercept should be negative 2. Look at that. Okay, I might have messed up earlier, but I just feel like I recovered from it now. It literally goes exactly through negative 2. Pretty excited about that. It doesn't take much to excite me. Okay, so there's a second example of how to use a point and a fake point, the fake point temporarily, so that you can actually find the slope at a very specific point instead of between 2 points. So if you're reading in a calculus book, here is the fancy definition that you would see in a calculus book. The slope of the curve y is equal to f of x at the point P. So you've got some kind of, here's your y is equal to f of x. You've got some point P. Let's put it over here. It doesn't really matter. A comma f of a. What's your point? Point P. Is the number the limit of f of a plus h minus f of a over h? And if you're thinking, that doesn't look like what we did. No, it is. I'm going to show you. The second point, the dummy point we made was, that wasn't to be mean. They often say like a dummy variable or a dummy point when it's like a placeholder of some kind, okay? Meaning it doesn't actually matter. So it's even used in bridge, the card game. So a plus h, comma, f of a plus h. Remember that's what we did? We took whatever the number was and we added h, and then we also figured out the function with the new a plus h. And then that would make the slope equal to f of a plus h, y2, minus y1 over x2 minus x1. But you will never, ever, I have never seen this written this way in a math textbook. They always simplify this part, which makes me a little sad because I feel like it's much easier to understand if you leave those two in there. So if it helps you, write a plus h minus a. That's actually what's happening. It does always simplify to h, but it helps you understand the concept that it's really y2 minus y1 over x2 minus x1. But because these do cancel, h can't be 0, which is what would make it perfect. So they've added in the limit. So here is the fancy calc definition that you would see in a textbook. Very important that you learn this year how to read mathematical textbooks, because you could definitely have a professor you don't understand, an online class, imagine that made no sense, and you're going to have to look things up in a book. So I'm going to try and improve your reading skills. The tangent line to the curve at P, so this tangent line touches really briefly. Notice, see, it doesn't even, that line would look different if I actually used the red point. But the line with that instant slope, that slope only at point A, the tangent line has that slope. So you're going to hear about tangent lines and slopes and things like that. They all fit together. Okay. All right. So we're going to do another one to make sure you got it. Let f of x equal x squared minus 4x. What's the first thing you should do? I hope you said to yourself, graph it. Really want you to be making these graphs. It helps you know if you've done the problem correctly. It gives you a sense of what you're looking at. And it's so easy. You factor. There's an x-intercept there. There's another x-intercept there. It's a positive upward parabola. It definitely looks like this. That was not that hard. It was like 15 seconds. Do it. Find the slope of the curve at 1. So at x is equal to 1, I want to know the slope right there. So that point is 1 comma. All right, now when I actually plug a 1 in, I get -3. So I didn't make a really great graph unless I go like this. 1, 2, 3. Look at that. That is a good graph. No, it's not a good graph, but it'll give you a sense of it. If you are trying to get it to be perfect, then you could always find that point first, and then it would be very easy to make a much better graph. So it crosses at 0, 4, 1, 3. It looks something like this. So it's steeper than what we said, which could be important if you were trying to check your tangent line. All right, so at 1, I want to know the slope right there. I'm going to go a little faster now. What do I need to do this? I need 2 points. This is the point 1, -3. My second point is 1 plus h, comma, 1 plus h squared minus 4 times 1 plus h. You have to put the 1 plus h in that equation. I would take the time to simplify it. So h squared plus 2h plus 1 minus 4 minus 4h, 1 plus h comma h squared minus 2h minus 3. So here's my 2 points, 1 negative 3 and 1 plus h squared minus 2h minus 3. The slope is going to be the limit as h approaches 0 of y2 minus y1 over x2 minus x1. Don't forget to rewrite the limit in order to have proper notation. These cancel. And you can go ahead and factor now if you want to. H times h minus 2, you know you're going to end up factoring, over h. This cancels. When I plug 0 in, I get negative 2. That is the answer to find the slope of the curve at 1. Does it look like it could be the answer? Does it look like that slope could be negative 2? I don't know. Maybe I still drew it wrong. It looks actually steeper than negative 2. But it's negative. It's fairly steep. I feel good about it. Now I want the equation of the tangent line. Remember, for the equation of the tangent line, start here. You just need slope and then x minus the point. Okay? So you need your slope and then x minus the point. So minus 1, minus 3. Okay? There's your point. And now I have the slope, the negative 2. Done. Box it. I'm not going to box it. I made it too messy. I'm going to rewrite it. Oops. You do not have to simplify this. Just going to keep saying that. You do not have to simplify this. Unless you're doing homework from a book or someplace where it is written out differently. In order to check it, you might have to. Negative 2x plus 2 minus 3 would be minus 1. So, I didn't actually draw the tangent line, so now I can't tell you if I was awesome. But I can try and draw it through negative 1. Yeah, I mean, it definitely looks like it could have gone through negative 1. So I feel good about this answer. All right, and the last one that we're doing right now, we're gonna make a little shift, and that is that we're gonna write a general formula for the slope of the line tangent to this function at point A. This is actually going to be our real goal. What we've been doing so far has just been a warm-up to get you to this point. This is the goal for today. What do I want you to do first? I want you to graph it. Please graph it. So x times 2x minus 1, it crosses at 0 and at positive 1/2. So it's right there. It's really tiny. Okay. Which makes sense. That made it a little steeper, and it is going up, and it does have a slope of 2. So I'm just going to pick any random point. I'm going to call this A. And how do we find a y value? We plug it into the equation. So the y value is 2a squared minus a. Now I need a second point. Doesn't matter if you move it left or right. You can put it wherever you want to. And this point is a plus h. And then 2 times a plus h squared minus a plus h. You got to plug it into the equation. So I always take the time to simplify. A plus h. If you want, you can pause it and then just skip ahead and see if you did it right. 2 times a squared plus 2ah plus h squared minus a minus h. A plus h. 2a squared plus 4ah plus 2h squared minus a minus h. So the slope between those 2 points, which are not specific, just a point A and then the nearby point A plus H, is still going to be done the same way. The limit is H approaches 0. And in case you've been missing this, because if h was 0, if h was equal to 0, then the second point would be a 2a squared. If h is 0, this goes away, and that goes away, minus a would be the same. So you say you've picked 2 points, but you haven't. If h is equal to 0, you've picked the same point. But you can't let h be 0, because then when you try to do the slope, you'd get 0 on the bottom. So y2, I always do the longer one first, less distributing of a negative that way, minus y1, remember the parentheses, you got to subtract the entire y1 over x2, a plus h, minus x1, which is a. Now, I know there's some smarties in this class that are literally always just going to write h on the bottom. You go for it. I don't mind. And AP test doesn't mind either. But I like to write this out every time after all these years, because I like to see y2 minus y1 over x2 minus x1. But I know what you guys are like. You do what you want. So if I distribute this, then now the plus a and the minus a cancel, and the 2a squared and the negative 2a squared cancel. So with what's left, you can predict. You're always going to be able to factor out. But I'm just going to show the extra step to make sure that I'm not losing anybody, since this is the last example. So I take the h out, and I get 4a plus 2h minus 1 all over h. The h's cancel. And now that that's gone, I can plug in 0 and not have a problem. When I put a 0 in, it only goes right there. Okay, so I'm going to plug in h is equal to 0, and I get 4a minus 1. All right, this is the key. This is the most important thing of the day. What you have just found is a general formula for the slope at any point A on the curve. This, in my opinion, is super cool. So hopefully you are well beyond this section. So I'm actually going to erase this section so I can use my graph and show you what I mean. So if I said to you, remember this goes down and it goes up through 1/2. That's where it crossed. So if I wanted to know the slope at 1, so at 1, what is the slope? So at x is equal to 1, the slope is 4 times, I know it says a, but meaning at any point a. So at a is equal to 1 if you want. 4 times 1 minus 1. The slope is equal to 3. Right there, slope is 3. Now I would expect that as you got bigger, x or a is equal to 2, right? The slope should get steeper and steeper, and it does. 4 times 2 minus 1 is 7. So the slope gets steep pretty quick. Where would you expect the slope to be negative? At x is equal to negative 2, right? At negative 2, I expect it to be some really steep negative slope. This is the formula. Negative 2 minus 1, negative 8 minus 1, negative 9. It is super steep. And where would you expect the slope to be 0? Right at the vertex, which, since we crossed at 0 and 1/2, the vertex should be at 1/4. And sure enough, 4 times 1/4 minus 1 is 1 minus 1 is equal to 0. Right there at 1/4, the slope is 0. So this, in my opinion, is just amazing. Not only have we invented a fake point, we invented 2 fake points, and we use them to make a formula that will allow us now to find the slope anywhere along the curve. And that is truly the key to calculus. This concept right here, so if you're not getting it, you need to make sure you come back next lesson and I'll keep explaining it. So this is going to be the key. This equation right here and all the amazing and powerful things that it does is what we're going to spend our year studying, is why the slope along a curve is so important. All right, so real quickly, the next few pages are practice problems. I'm going to write the answers at the beginning of the next video. You can watch just the next video, just the beginning, and just look at the answers. If you get these practice problems right, do not sit through the video. That's fine until you get to number 6. I will say that number 6 is an extremely challenging problem. So please, if you're gonna do the practice problems, you can try number 6. That would be fantastic. If you worked on it together in a group, that would be fantastic. But I will do it by video if you want to come back and watch that on the next video. Otherwise, you guys have a great day.